we go. Good morning to my grade 12s. Welcome to our last period of the week. Well, 2 periods before weekend. Yes, let's get started. This one I'm recording as well. Yesterday we had a discussion on how to prepare for mechanical assembly. We did our planning with the hatching, and now we're going to start the drawing. Because this is our first drawing of the year, I want to quickly show you the memo of this page so that you have an idea in your head how it's going to look, how it should look like at the end. So here's the answer. So it's the sectional front view and then the right view, just redrawn. And what we're going to do is we're going to draw them at the same time, jumping back and forth. For instance, if I have this bolt construction here, nut construction here as well, already, I can just project these lines over or measurements to draw it here. So you'll see it now when we start drawing. We just want to show you how it looks like. So this is the end result. Okay. Okay, first things first. So we check if there's anything else I missed. No, okay. You start with a blank page, obviously, but now you have to plan out your page in front of you so that you can actually fit in the entire drawing. So what I usually do is I take the largest measurements from both views as a measurement of where to start my drawing. So what I mean of this is my right view, this pulley will definitely be the biggest part. If you look at the picture, that pulley is going to be huge. And then partially this base or bracket will also be included. But I'm going to use the pulley as a form of measurement. It has a diameter, so that means length and breadth, of 158 millimeters. Okay, so I'm going to keep that in mind. Let me just write it down here. Okay, 158. Then for my front view, I'm going to use the pulley as well as a height, but for the length, I'm going to refer to the bolt because everything fits onto the bolt. So that will be the longest part of the front view. So that's 82. Now what I do is I'm going to change 82 to about 100 millimeters. I make it a lot bigger for myself. And I'm going to make 158. Let's make it 180. Now I go to my page. Now I know this is, since this is third angle, and we need to draw a sectional front view and a right view. The front view must be here, and the right view must be here in third angle. Okay, so let's start with the right view. My right view has to occupy the left side of my page. So the maximum size of the right view is 158 millimeters, but I've enlarged it to 180. So I've overcompensated. So that means I need plus minus about, I don't want my drawing against the side of my page. So I want about, if that's 180 there, and that's 0, that's about the space I need. So I'm creating space for my drawing. Same thing for, let me just put the camera closer. That's for the length. Same thing for the length. So there and here. Now for the height, it's also 180. So somewhere in the middle. So this, I'm just eyeballing this. This doesn't have to be perfect. It's just that you have an idea if your picture will fit in. So, okay, so I've made myself little light drawing or marks where my right view should fit in. So I know there's enough space. If I don't do this before I start, the problem that happens or arises is you start drawing And then after a while, you realize, oh, my picture is going to go over my border. So this is just to plan out your picture if it's just a blank page. Now for my front view, I'm going to use the height of the pulley to mark it there, but I just want the length here. And the length according to the information is 82, so I made it 100. So I've overcompensated again. Okay, there we go. So now we know where to start. If my calculation was off, there's enough space here to still draw something. There's some space here between the two views. If I go back to the right view, there's a bit of space at the top left, and there's a bit of space at the bottom left. So this is what I usually do just to plan my picture, so that I don't get caught out that my picture doesn't want to fit in after a while. I hope that makes sense to you. You don't have to do this, but this really helps me to plan my picture. Okay, next thing. When there's two views to draw, I usually start off the one that does not need to be hatched. And then I take measurements over to the other side. So that's what I do. So I'm going to start with the right view, and then as I'm drawing, move back to the front view. So for the right view, if I'm looking at the picture, I ask myself, if I'm looking from this side, what components will I be able to see, and which will be hidden because it's behind something else? We will see the nut. We will see the washer. We will see the entire pulley. Will we see the bush? No, it's hidden behind this pulley out of view. We'll only see this part of the bolt, and we will partially, so I'm going to take it halfway. We're going to partially see this view. I'm just trying to think, will I see the grub screw? I don't think so, because it's going to be behind this. We'll just check at the end, but I think it will be behind the support structures. We won't see it. So now I know where to start. And then what I also do is, when I start off the right view, I start with what's in front and I move backwards, because if you start at the back and you draw the entire object, then you'll have to go and erase some of the parts when you start adding things in front of it, because you won't be able to see it. And they said specifically, no hidden detail. So to save time, I'm going to start in front. So the first thing I'm going to do is, I'm just going to make one big circle to represent the outside diameter of the pulley, which is, just want to check again, it's 158. 158 divided by 2, that's 80, that's 79. $79. Now I've made marks for myself, but it doesn't have to be on those marks. They were just there to act as guides. So there's the outside circle of my pulley, just to see if everything fits in. And then just want to make a mark where my center is. Right. And immediately, I'm going to add my center lines, because I always forget to add the center lines especially when I was at school. This is always something I forgot. You don't lose a lot of marks, but I mean, it's marks that you should actually easily get. So I add my center lines immediately. For those who came a bit later into the lobby or Zoom session, I am recording this. So you can always refer back to this when preparing for exams, or if you missed something. So this has been recorded since we started on page 9. Okay, what I'm going to do next, I'm going to now draw the bolt and the nut itself. And then I'm going to quickly just stop and ask if there's any questions, if you have any questions at this point in time, and then we'll continue. So let's just do the axle, not the axle, sorry, the bolt and the nut itself. So I'm now going to draw this. I'm going to draw that part of the bolt, but you will only see the inside that sticks out in front of the nut here. Okay, now let's talk about the nut again. There's some calculations that you need to know. Do it here next to the nut. So the nut is M24, which means it's the metric system. That's what the M stands for. And there's a recipe how bolts, nuts, and washers are made so that the ratio between the components stay the same, no matter how big or small the system is. So for M24, if I want to know what's the diameter from this of this circle, that circle there, the calculation looks as follows. It's the M value times 1.5. So it's 24 times 1.5. So that's 24 times itself. That's 24. And the half of 24, which is 12. So 24 plus 12 gives you 36. Okay, got that. If you want to know what the gap between the inside and the outside little circle, so that space there, that represents the threading. The formula looks as follows. It's the M value times 0.1, which is 24 times 0.1. So you just move the decimal one place. So it gives you 2.4. So you can either work with 2.5 on your ruler, or you can work with 3 on your ruler. 2 on your ruler. So that's up to you. Whatever seems the easiest to you. That 0.5 decimals is so small that it won't matter. Just want to see if there's something else. Sometimes they don't give you the height of the nut, and then you work it out by times M with 0.7 or 0.8. I've seen both formulas, so 0.7 or 0.8 if they don't give it to you, but it's given. Okay, so the radius of that circle is 36. So the diameter is 36. So the radius is half of it, which is 18. Now let's draw it. You can either use your ruler to set your compass, or what I usually do is I use this ruler on my board. Okay, there's 18. Okay. And now I'm going to draw the hexagon around this circle so that I can complete the bolt. I always confuse the two, the nut. The bolt is the one attached to the shaft, and your nut is the loose component you put onto the shaft, if you were wondering what's the difference. Okay, according to the picture, one of the sharp ends has to be at the bottom. So if you forget which set square to use, what I usually do is I go back to the question and I put the set square next to it, keeping this part plus minus parallel by eyeballing it. And as you can see, now where it lines up. So if I turn it around for the 30 degrees, there we go. Okay, so I have to use this side. Now this is all construction first, and then afterwards I'll darken the lines. This being askew. Okay, so there's the nut. And now what I still have to add is the bolt on the inside. Now for the bolt, it is the outside part of the bolt is that M24, so that is the diameter, so it's 12. I'm just setting the compass. And then I'm also going to add that 3/4 circle on the inside to represent the threading. Now to work that out, that's where you multiply with 0.1. Where is that? There. Where I multiplied with 0.1, where I got 2.4. So you're going to minus 2.5 or 3 or 2, or 2 from the radius of 24, which is 12. So that's going to be 10. And the 3/4 could point any direction as long as it should not be a complete circle. So as long as there's some kind of gap pointing in any direction, that's fine.
Sir?
Yes.
So why in the picture that they gave us did they put the threading on the outside, but we put the threading on the inside?
Yes, I was hoping someone's going to ask this. Okay, that's a very good question. What the Lisa is asking is, here the 3/4 circles on the inside, but why on earth is it here on the outside? And I just want to compare the two. There's the nut threading on the outside. There's the bolt threading on the inside. Now, what does that mean? Let me show you. I'm going to quickly go, I just want to quickly get a physical bolt and nut to show you the difference. Okay, so here's an example of let me just put it a bit higher. So here's an example of a washer, a bolt, and a nut. So there's the nut, there's the bolt, and the washer. Now, if you look at the bolt on its own from this view, so that view there, I'm going to bring it closer, but then I'll just have to focus on it. you should be able to see the threading if you look carefully around. I don't know if that's so clear on your camera or on your screen, but there's threading. So it's basically, it's a circular object, and then there's threading cut into the metal. Okay, so that's why the threading is on a bolt on the inside. But with a nut, the material is on the outside and the threading sticks out on the inside. So it's swapped around. So it's two opposite poles of the same thing so they can fit into one another. Okay. So what's the purpose of my explanation? If you draw a nut on its own and it's hollow, there's not a bolt inside it. This is how you draw it, with the threading on the outside. But because we are drawing our answer with a bolt and nut connected to one another, you're going to see the bolt actually. That's why we then draw it this way. Okay, so if this nut was empty without any bolt screwed into it, it would have been swapped around. So then this quarter circle would have been this one, and this one would have been the quarter circle. But because there's a bolt on the inside, if we look at our 3D drawing, the bolt passes through all of it. So even through the nut, this is how it will look like. I hope that answers your question.
Yes, sir, that makes sense. Thank you.
Okay. Now, before I continue doing the next step, is there any questions up until this point? So I've just drawn the outside of the pulley and the nut. Yes.
So, where did you get the dimensions of like the circle in the middle, the bigger one?
Yeah, good question. So the dimension of that circle is the size of the bolt itself. So in other words, the outside circle, that's the value of M. So it's 24. But that's the diameter. So I just divided by 2 to get the radius. Okay, and then for and then for the inside circle, it was the value of 24, the M value, times by 0.1, which gave me 2.4. So I rounded it off to 2, subtracted it from 12, the radius, to get 10. So the outside has a radius of 12, and the inside has a radius of 10.
Thank you, sir.
Okay, is there other questions?
Sir, I just want to ask with the other method, because I saw in the book, apparently you times with a nut, you times by 0.8 and a bolt by 0.7. So I wanted to ask for like what component do we use those formulas for? Or yeah.
Okay, good question. So I'm going to write it. Okay, I'm going to use the Afrikaans side of the page just to show it again. So don't worry about the words. I just want to show it where I haven't made notes yet. So let's see where I'm going to start. I'm going to start here. So M will always be the diameter of the bolt. That's always what M stands for. So that's M. This is M. Then the diameter of your nut and bolt is always M times 1.5. So in this case, 24 times 1.5. The height of the bolt and nut. Now, what I was taught is a nut is always M times 0.7. But if they gave it to you already, that's a different story. If it's not given, that's your formula.
Oh.
And then for a bolt, now this is a bad example. This one doesn't have like a proper bolt at the back, but I'm just going to write here. Then for a bolt, it's usually M times 0.8. So the bolt is a tiny bit longer or higher than your nut. And then, so far we've got M is that part. The
Yes, sir.
radius of the, the diameter of the nut and bolt is 1.5. You times it. The height of the nut is 0.7. The bolt is 0.8. And then the one that we don't often use because it's always given for a washer, the that height, you times m with 0.2, and the diameter is m times 2. I think what I'm going to do is I'm going to make a note here in my diary. I'm going to send this on the group. I'll quickly make a summary of this. I'll just write down bolt this formula. And so I'll just, when we're done with class, I'll just write that summary. Summary for grade 12. Okay, so I'll quickly send that as soon as we take a break. Does that answer your question? Okay, good, good.
Yes, sir. Thank you, sir.
Okay, another question. Just giving a few seconds. Okay, our time at the moment is 11:55 or 54, and we have a double. So let's take a break from up until around about 12. Then I'll start the Zoom meeting again. Then I'll quickly post the summary of those formulas. You can quickly grab a cup of coffee or whatever you'd like to get, drink, stretch your legs, and then we'll be back for our second round. See you guys now in a few minutes. We'll be back around about 12 or just after 12 for the second period. All right, grade 12, see you in a few minutes.
Thanks, sir.
Okay. So to recap what we are busy doing. We have started with our first chapter of grade 12 EGD, which is mechanical drawings, which we have done last year as well. There's nothing actually new to mechanical drawings this year. It only gets more complicated, the drawings itself. We are busy with our first example of such a metric drawing, page 8 and 9. We have planned out, let me just turn this around. We have planned out our drawing. We have planned the hatching. We have worked out our spacing, and we were busy with the right view. And I ended by finishing the part of the bolt and the nut. Now we can continue. If I look at my page, the next thing I can add, the next component that's behind my nut is the washer. So I'm going to add the washer, which has a diameter of 44. That means it has a radius of 22. Okay, there's the washer. Next is to finish the pulley. And then as soon as my pulley is done, I'm first going to jump to the front view, start drawing there, and then go back and forth as I need to. Okay, so let's finish the pulley itself. I think I'll need to make this a bit higher. Okay, now to finish the pulley. And this is basically finishing, just copying and putting this in. I'm not going to include the hidden detail. They didn't ask for it. We won't see everything on the inside because there's a nut in front, but we'll see most of the other parts. So I'm going to start by drawing those other circles. So those inner circles there. It's 1, 2, 2. So that 1, 2, 2 divided by 2 is 50, 61. One. next one. This circle they didn't give us on this view, so it has to be on the other side, and I think I found it. If you look at that 13, it's basically telling us that from the outside circle inwards, you subtract 13. So in other words, it's 158 minus 13. So not only is your password hard for Zoom, sometimes the measurement is not given to you in a straight manner, but you have to work it out a bit. So it's basically it's 158 minus 13. No, I'm lying. 158 divided by 2 because I want the radius. The radius I'm going to subtract by 13. Okay, 66. Okay, there's the pulley. Now I have to add the support structures, or here's the other word for the spokes. And it says here, ooh, that's a funky word, equer spaced. Wow, okay. That basically means, I've never heard the word before, but the equer tells me, and I can see it, that it's equally spaced out. So in other words, the degrees between them are equal. Now, how on earth are we going to work this out? Easy. We're going to take 360 and we're going to divide it by 5, 72. So every single one of them is spaced out 72 degrees from each other. This one is exactly vertical, so I'm going to start with that one. That's easy. The others is a bit more complicated. So it's 8, so it's 4 on each side. Oh wait, before I do this, just want to quickly check that circle on the inside. What's the size? It's 54. Which is bigger than the washer. Okay, so wait, before I draw it, I forgot about this circle there. 54 divided by 2, 27. There we go. Now I can draw it. Now I can start doing the spokes. The equer, I don't know how you say it, the equer spokes. Words of the day, equer. Okay, to get the rest, what I'm going to do is, I'm going to take my protractor, and in the center, because that degrees it's in the center where you start from. So I'm going to start here. And from the right to the left, I'm going to measure 7. I'm lying. From there backwards, we have to measure 72. So a better option would be to do this. Put the 0 in the middle of that spoke. And then go and measure 72. I'm going to use a red so I don't get confused between the other lines. So there's the one side. Same on the other side. Yep. Just going to first connect them together. So this is not the spoke. This is the center of the spoke. There and there. And then just for myself, I'm going to make, no, that should be fine. Now the same thing again. $72. Okay, cool. Now just to add the thickness. Now, oh, sorry, I think the camera actually, hello. Okay, here we go. So I've got the centers of the other four. I've marked out 4 on that side, 4 on this side. Now, how do you draw the line so it's parallel to your center? You make your own T-square. Do this. You put it down on that line. Take your other set square or ruler. Now just move it upwards. So now you see I can move it up and down, but it stays parallel to that center line.
So can you explain the step again?
Yes.
I need to.
Are you talking about how to draw, this part
Yes.
that I've just done?
Yeah, yeah, yes, sir.
Okay, so I've got 3 more to do anyway. So let's take this line, for instance. So that is the center line, but it has a thickness of 8. So I take a ruler, put it on 4, 0, and then on this side 8. But now I can't just go and draw lines, because how do I make sure that it's parallel to the center line? I'm going to make my own T-square. I'm going to do this. Line this ruler up. It could be the other one as well. Line it up with the center line. Put the other set square against it. Press hard on the secondary set square so this one can move around freely against the set square, staying parallel to your center. There you go. Now let's do it again with this one. So it has to be 8. So 4 on the one side, 4 on the other side. Now I'm going to swap them around just to show you can use either or.
So.
Yes.
No, I'm saying yes, sir.
Oh, okay. Sorry. This one I can either put there or here. So I'm going to put it there. Now I'm going to press hard on the secondary set square. Now I can move it back and forth. If you have to release this one, just press hard on the other one again so that you don't lose your position. Move. Do it again. And now the last one. This time I'm gonna put the other set square on this side, but you'll get the same result.
Oh, I see. Okay.
Say good, good. Now I'm going to stop here on the right side, not for the class, but just going to stop with the right. I'm going to go over to my front view, because what's behind the pulley is the bush and the bracket. The bush we are going to be able to see, and the bracket we're only going to draw partially. So I'm going to rather draw it in full on the right side and bring it back to the right view. So you may jump back and forth from one drawing to from one view to another. That's something I would recommend you should do. It makes it easy. Okay, so I'm going to go to this side. I'm going to still keep a part of the front view visible so you can see it. Oh, sorry, the right view, because I'm going to need some of those measurements. Okay, so you can still see it kind of. Now, the two pictures need to line up with one another. So instead of going and just guessing where to start, I'm just going to extend this center line to this side, because there's also a center line in the middle of the shaft, because it's a circular device. Okay, so the shaft needs to be on that line, and that line will be the line of symmetry. And I made two marks there for myself at the beginning. So the shaft should fit in between those 2 points, plus minus. So now the next thing I'm going to draw, I'm going to start, okay, when it comes to the cutting part, so for the right view, I started from front moving backwards. For the sectional view, there's no front or back, it's one flat surface. But what I usually do is I start with the inside component moving outwards, or inside component, and then as the components slide onto that the shaft one by one, that's how I draw it. So I will start with 7, then 5, then put 6 into place, 4, 3, 2, 1. That's how I would have done it. There's not you don't have to do it in this way, but this is what I find to be the easiest. Now, the shaft I'm going to draw, but I'm going to keep most of the shaft in construction, because we do not cut through a bolt and washer, for instance, and a nut. That's a EGD rule. So I don't want to go and raise unnecessary lines at the end. So I'm going to start somewhere in this vicinity. So let's say I start there. I'm going to start here at the back of the shaft. It has a diameter of 32, so that's 16 and 16. Okay, to draw the front part of the shaft, I'm not going to go and measure anything with my ruler. I already did the calculations over there. There's the same shaft. So where you can save time is just to project this backwards, or project it from the right side to your front view. So from there and from there. Something feels off here. Why is that thing so short? I should check. I think I made a mistake. I made a mistake. Let's see. 32. It looks correct, but why is that so short? Sorry guys, just want to check. I think my ruler might have moved. I think that's what happened. This ruler, my page moved a bit. Just want to check something. Okay, that's better. It still looks off. That's so weird. I don't know what I did wrong here, but now for some reason it doesn't want to line up. It's 32. Just want to check again. Yes, it's 32. And it's 16 from day to day and 16 from day to day. Okay, so I think my page moved a bit now. These lines are not lining up. So what I'm going to do is I'm just going to quickly manually add them just to check. So it's 24, so it should be 12 on both sides. So there. There. I'm going to work with that. Okay, so there's the shaft. I'm going to leave the shaft like it is. I'll finish it at the very end, but for now I'm just going to start stacking the components on top of it. Okay, I think the next thing I'm going to do, instead of doing the bracket first, I'm going to start with the little grub screw that has to fit in there. The angle of the grub screw is 30 and the diameter is 9. So that's 4.5. I'm going to get closer to the grub screw for you guys. Then there's a little groove on top of the grub screw for that's for a screwdriver to actually tighten this grub screw in real life. It's a 2x2, so that means it's one there, one here, and then downwards 2. Okay, and don't forget the grub screw is also a circular object, so center lines. Now, since the grub screw is only entering the shaft at a tiny part, we don't have to hatch the entire shaft. We call this partial sectioning. So what we do is take a freehand and you make this weird cloud shape. And then on the inside, you hatch it. My rule is usually the smaller the hatching surface, the bigger, smaller the hatching. So with bigger objects, it won't take you forever to hatch it. So the bigger your spacing between the hatching, the smaller the opposite. So there we go. Our time is 5 minutes left. So on Monday, there's no homework. On Monday, we'll continue to draw this together. So we just need to finish the front view and then add a few things to the right view. And then that will be our mechanical drawing. On Monday, before we start, if I remember, we'll just quickly take a few questions if there is, and then we will continue. Grade 12s, I hope you enjoy your weekend, rest well, and come back on Monday fresh and ready to work again. I'll probably by Monday, if there's no other errors, start making use of MS Teams as well. But obviously, we've got WhatsApp as backup, and my ebooks will always be used as well. So if the one platform doesn't work, you will have access in other forms as well. This video is recorded, so I'll just process the video a bit later and then post the link to you. Bye, grade 12.
Okay.
See you then on Monday. Enjoy the weekend.
Bye,
sir.
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 Bye, meneer.
Bye, sir.
Bye-bye.
Bye, sir.